All right, good morning, class. Sorry, I feel not well at all. So, sorry I'm not able to be with you today. But here's a few notes on section 8.3 is what we're looking at moving on to next. It's titled Graphing Reciprocal Functions. Or graphing rationals is another way to think of it. But we're going to start with the parent function. Understand a little bit about what the graph is going to look like, and then we can do our transformations from there. So our parent function would be y equals 1 over x. So I'm going to make a table of values. First of all, think about domain restrictions. Your x is a denominator, so therefore it cannot be 0. You can have positives, you can have negatives, but you cannot have 0. So I'm going to pick some numbers that are negatives, skip the 0, and then also pick some positives. I probably could pick more than this, but you just have to trust me a little bit on what the pattern is. So let's plug them in. So if I plug in negative 2, 1 over negative 2, well, that's just negative 1/2. 1 over negative 1 is negative 1, 1 over 1 is 1, 1 over 2 is 1/2. So if I were to graph this now, so we know we've established that x cannot equal 0. So if x can't equal 0, that's going to be a vertical asymptote. So that's this axis right here, your y-axis. So when I have negative 2, I get negative 1/2. At negative 1, I get negative 1. At positive 1, I go up to positive 1. Positive 2, I go down to 1/2. Now, that's not enough information to necessarily know exactly what this picture looks like, but if you think about what would happen after that, if I went to 3, I'd have 1/3. 4 would be 1/4, 1/5, 1/6. It's getting closer and closer to 0, but it's never going to hit it. And then as I travel to the left, if I plug in like 1/2, I end up with 2, and it's going to approach this asymptote. So over here, it's kind of bound into this quadrant, because I actually have an asymptote that's vertical, but I also have a horizontal asymptote. So the horizontal asymptote, it's a y equals equation. Since it's horizontal, it's at 0. So that's this x-axis here. So your graph can't touch that either. So this one's bound into this quadrant over here. You just kind of have to follow out those asymptotes. We call this a hyperbola. Looks like hyperbola, but hyperbola. So we call it, each of those is a branch of the hyperbola. So now let's look at some transformations along with that. Let me give you the generic form. Y equals a over x minus h plus k. H and k are going to be translations, as we're familiar with. H is going to be horizontal translation, k is going to be a vertical translation, and then this a is going to determine if it's larger than 1, it's going to be a vertical stretch. If it's less than 1, it'll be a vertical compression. If a is negative, it's going to reflect, kind of like the transformations we've already encountered. So let me give you a problem now. Let's go with y equals negative 2 over x plus 4 plus 1. So if you think about the denominator can never equal 0. If you let x plus 4 equal 0, you would get x equals negative 4. That's your vertical asymptote. So x equals negative 4 is the vertical asymptote. Our horizontal asymptote, as before, is always a 0 unless we have a vertical shift, and we do have a vertical shift here. My k value is a positive 1, so that k value determines our horizontal asymptote. So my h value determines vertical. Remember, you have to do the opposite sign. And my k value determines the horizontal asymptote. So if I do a table of values, I'm going to surround negative 4. So I'm going to do some numbers to the left of negative 4, some numbers to the right of negative 4. So I want both branches of the hyperbola. I don't want to pick 0, 1, 2, 3, 4, or something like that, because they're all in the same branch. That doesn't really help me. So let's plug in negative 6. Your denominator becomes negative 2. Negative 2 over negative 2 is positive 1, plus 1 is 2. plug in negative 5. My denominator becomes negative 1. Negative 2 over negative 1 is positive 2, plus 1 is 3. When we plug in negative 3, my denominator becomes 1. Negative 2 over 1 is negative 2, plus 1 is negative 1. And plug in negative 2, my denominator becomes 2. Negative 2 over 2 is negative 1, plus 1 is 0. So at negative 4, I have a vertical asymptote. At positive 1, I have a horizontal asymptote. So before I graph, I actually created 4 new quadrants. There's a quadrant here, 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 here. It's the 4 quadrants in relation to my asymptotes. My hyperbola is going to be in 2 of those. Let's find out which 2. Negative 6, positive 2, negative 5, positive 3. So you can see, based off of those asymptotes, what quadrant they're in. So I can follow in an asymptote, hit the 2 points, follow out the other asymptote. And then negative 3, negative 1, and negative 2, 0. Now hit those 2 points and follow in and out the asymptotes. Don't ever cross your asymptotes. So there's my hyperbola. Notice it has been reflected from the parent function. The parent function, the left side was in the lower left quadrant. Now I have the left side in the upper left quadrant. And then the right part was in the upper, now it's in the lower. So it's been reflected. That was because that a value was a negative. Because the a value is 2, it's growing at a faster rate than our first one. So it was a stretch. I haven't really talked about domain and range. Your domain, you can graph everything except for your negative 4. Your range, you can graph everything except for your positive 1. So I'm going to say it this way. For your domain, x does not equal negative 4. For your range, y does not equal positive 1, inferring that all other real numbers are okay. All right, so that's all I'm going to give for notes. Your assignment is listed on Canvas, and I plan to be back tomorrow even if I don't feel well.